Hello everybody, getting ready to do lesson 8.2 part 1 pre-calculus math today classwork. And today's lesson has 10 points that will go into your notebook, and then 50 points will go on your classwork sheet. This is arithmetic sequences and partial sums 8.2 part 1. Students in my classroom, student put your name, date, and period. Online students, put your due date here. And into our class bell work today, students, teachers. Today's bell work, use Gauss-Jordan elimination to solve the system of equations. So we're going back into chapter 7 here, students. This should be review. Gauss-Jordan elimination. To solve these, give your students 5-6 minutes. Teachers, see you in 6 minutes. Welcome back everybody for the solutions for today's bell work. For 103 up here, this we got a 3 by 3 here, and then for this one here, this row will reduce to this, and you should come up with your solution column here of 1, 5, -1 for this solution here. Here is your kind of like your reduced echelon form here of Gauss-Jordan, and these hash out to being 1, 5, and -1. Here's your ordered triplet for this matrix here. And then down here, your solutions, your ordered triplet will be 2, -6, and 3. Again, here's your reduced row echelon form for this system here. 2, -6, and 3. To today's lesson, we go right into a notebook here. Arithmetic sequences. A sequence whose consecutive terms have a common difference is called an arithmetic sequence. So the definition of an arithmetic sequence: a sequence is arithmetic when the differences between consecutive terms are the same. So the sequence like this, a1, 2, 3, 4, and a to the n, is arithmetic when there is a number d such that a2 minus a1 will equal a3 minus a2 equals a4 minus a3, etc. will all equal d. So you have an equal difference between numbers. The number d is the common difference of the sequence. So this goes in your notebook, students. On to an example here to show how this works. Examples of arithmetic sequences. The sequence whose nth term is 4n plus 3 is arithmetic. The common difference between the consecutive terms here is 4. Here's your common difference. 7, 11, 15, 19, and 4n plus 3. Begin with n equals 1, and then you go 11 minus 7 would equal 4 here. So begin with n equals 1. Here's an example here. Between 7 and 11, you have a difference there of 4, do you not? So 11 minus 7 is 4, 15 minus 11 would be 4, 19 minus 15 would be 4, etc. So when you begin with 1, your terms would be the output when you begin with 1. And then 7 minus 5n is arithmetic also. The common difference between consecutive terms would be -5. So here's your difference here between your terms. And you have 2, -3, -8, -13, 7 minus 5n begins with n equals 1. And then here's an example here where your -3 minus the -2 would equal -5. So there is your difference right there. And then C here, our third one, 1/4 of n plus 3 is arithmetic. The common difference between the consecutive terms now is 1/4. And then here would be our output here. So we have 5/4 minus 1 would be 1/4, and 3/2 minus 5/4 would be 1/4. 7/4 minus class would be 1/4. And then this would yield here n plus 3 over 4 is what that would simplify to when you begin with n equals 1. Okay, let's try one. Write the first 5 terms of this sequence here. Determine whether or not the sequence is arithmetic. If it is, find a common difference. Assume n begins with 1. Students, this is yours down here. So let's see how this one works up here. For number 11, the first term here would be 21. Our second term would be 34. And then our third term would be 47. 8 plus 13 times 3. And we're supposed to do how many terms? 5 terms, so 4 and 5. Our fifth term would be 8 plus 13 times 5 would be 73. So our difference here would be 13. The difference between each one of these outputs here would be 13. The sequence 1, 4, 9, 16, whose nth term is n squared, is not arithmetic. The difference between the first 2 terms is a2 minus a1 would equal 4 minus 1 would equal 3. And then, but the difference between the second and third terms would be a3 minus a2 would equal 5. So the nth term of an arithmetic sequence can be derived from the pattern below. a1 equals a1, so that'd be your first term. a2 would equal a1 plus d. That would be our second. And then a3 would equal a1 plus 2d. That'd be our third term. And then a4 equals a1 plus 3d. That'd be our fourth term. And then a5 would equal a1 plus 4d. That would be our fifth term. So here we go. Here you have one less here from a4 to a5 here, rather 4d here. One less would be a to the n would equal a1 plus n minus d. n minus 1 times d, that would be 1 less than n, the nth term here in that situation. Okay, page 6 here, the nth term of arithmetic sequence. The nth term of arithmetic sequence has the form of a to the n equals a1 plus n minus 1d, where d is the common difference between the consecutive terms of the sequence and a1 is the first term of the sequence. Okay, moving on to our next example here. Example 2, finding the nth term of an arithmetic sequence. Find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So with conditions like that, you know that the formula for the nth term is of the form a to the n equals a1 plus parentheses n minus 1d. Moreover, because the common difference d is 3 and the first term a1 equals 2, the formula must have this form here. So 2 plus 3n minus 1. We know this and we know this here. Substitute 2 for a1 and 3 for d. Or a to the n equals 3n minus 1. So when you multiply through by this, 3n, and then negative 3, that'll come out to negative 1, 3n minus 1. The sequence therefore has the form of 2, 5, 8, 11, 14, 3n minus 1. The graph of the first 15 terms of the sequence is shown. Notice that the points lie in a line, so here's your graph here. This makes sense because a to the n is a linear function of n. In other words, the terms arithmetic and linear are closely connected. So here's a graph of this sequence here. Let's try one. Find a formula for a to the n here for the arithmetic sequence like this here. So what do we do here? A to the 1 is 1, and then d is equals 3. Students, is yours down here. So up here, So a to 1 is 1, d equals 3. We plug that into our basic template here, and we get 1 plus n minus 1 multiplied by 3, and we end up with 3n minus 2 for our sequence. Okay, moving on here into example 3. Writing the terms of an arithmetic sequence. The fourth term of an arithmetic sequence is 20, and the 13th term is 65. Write the first several terms of this sequence. You know that a equals 20. Fourth term, or rather a to the fourth equals 20. And a to the 13th equals 65. So you must add the common difference d 9 times to the fourth term to obtain the 13th. Therefore, the fourth and the 13th terms of the sequence are related by a to the 13th equals a to the fourth plus 9d. A to the fourth and a to the 13 are 9 terms apart. And then when we do that, we come up with a to the fourth is 20 and a to the 13 equals 65. You have this situation here. 65 equals 20 plus 9d. And then you include that d equals 5, which implies that the sequence is as follows. A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 will be the same thing as this output here. So knowing that, write the first 5 terms of the arithmetic sequence. Use the table feature of a graphing calculator to verify your results. So our 8th term is 26 and our 12th term is 42. So knowing that, with 8th 26, 12th is 42. Here's our template here, and then d. So we have a to the 1 plus 7d here. So a to the 8th. So what do we got here? We got 4 terms here. And then when we multiply that through, we get a1 plus 7d. And then 42 equals a to the 12th. And then when we plug that back in here, we get a d here is 4. And our first term here is negative 2. Once we plug that into our original template, and then here are other, what do we got? 5 terms here. Here's our 5 terms, negative 2, 2, 6, 10, and 14 by using this template here. When you know the nth term of an arithmetic sequence and you know the common difference of the sequence, you can find the n plus 1 term by using the recursion formula. A to the n plus 1 equals an plus d. This is your recursion formula. With this formula, you can find any term of an arithmetic sequence provided that you know the preceding term. For instance, when you know the first term, you can find the second term. Then knowing the second term, you can find the third, so on. So using the recursion formula, find the 9th term of the arithmetic sequence whose first 2 terms are 2 and 9. You know that the sequence is arithmetic also. A1 equals 2, A2 equals 9. So the common difference for this excuse me, sequence is 7. 9 minus 2 is 7. There are 2 ways to find the 9th term. One way is to simply to write out the first 9 terms by repeatedly adding 7 to 9 like that. Or another way to find that 9th term is to find a formula for the nth term. Because the common difference is 7 and the first term is 2, the formula must have the form of 2 plus 7 times n minus 1. Substitute 2 for a1 and then 7 for d. And then therefore the formula for the nth term is a to the n would be 7n minus 5, which implies that the 9th term here would be 58. 7 times 9 would be 63 minus 5 would be 58. So let's try one now. The first 2 terms of the arithmetic sequence are given. So you got a1, a2, 5, and 11. What is a10 here? Use the table feature of a graphing calculator to verify your results. So by using your graphing calculator, students, you come up with A1, A2, and then our D here would be 6. So we got 5 plus 9 times 6 would equal 59 in that situation here. So we want to find 10 here. A1 would be 5. So A to the 10 would be A to the 1 plus 9D, which is 5 plus 9 times 6 would be 59 here. And then do the same thing down here, students, for your independent practice. And as your 8.2 Part 1, Pre-Calculus Math, here's my email, animatedpowerpointmathvideo@aol.com for class worksheets, homework sheets, note-taking guides, etc. Thank you.